All right, you ready? Let's go. X squared minus 64. What can you tell me about these two numbers or terms? They're special. How were they special? What's special about this? It's a squared, right? It's a squared number. What's special about this? It is squared, right? Something times itself equals 64, doesn't it? 8, right? What times itself equals x squared? X. What sign is this? Subtraction, right? So mathematically, what's another word for subtraction? Difference, right? Difference. So this kind of problem has a very special name. It's called the difference of squares. The difference of squares can be factored very easily. We get two binomials. What do I mean by binomials?
X times
It means there's two numbers or terms in it, right? Two binomials. Now the really cool part about these binomials is that the first term in each of the binomials is exactly the same. And it's whatever, God bless you, it's whatever the square root of this first term is. What is it? X. So here and here is X. The cool part about the second term in each binomial is it's the square root of the second term. What? 8. Okay, so this is 8 and this is 8. What are we missing? The signs, right? The signs. Okay? Here's the cool part about that. What sign do you like better? Okay, so some of you said positive and some of you said negative. Guess what? There's one of each. Boom. Okay? All right, so that was way, way, way too easy. So let me make it harder. Ready?
Yes.
Let's say, let's say, no, I don't want to do that. Let me figure out something really hard.
Oh, I've already got the first part.
The first thing you have to recognize is this the difference of squares? First of all, is it a difference?
No.
Is it a difference? Yes, it's subtraction, right? Okay, so just look at the first term. Look at the first term. What times what equals 25? 5. What times what equals x to the 9th? Ooh, so we don't remember our exponent rules, do we? Okay. Let's talk about exponent rules real quick, okay? If I'm saying x to the 4th times x to the 5th, what do I do if I'm multiplying like bases? You add your exponents, right? Okay? So what times itself is x to the 9th? Nothing, right? So let's change this to an 8.
What?
I said, let's change this to an 8. Now, can you tell me what times itself equals x to the 8th? X to the 4th, right? So we're pretty sure that this is 5x to the 4th, right? The square root of that? Is this term a squared term? What do you think it is? 7 y to the 3rd, okay? So does this have a square, or is this a square? Is this a square? Is it the difference of squares? Then give me two binomials. What goes in the first term of the binomial? 5x to the 4th. 5x to the 4th. God bless you. What goes in the second term of the binomials? 7y to the 3rd. 7y to the 3rd. What are the signs? Okay, I'm going to throw you off.
You have to have one of each.
Oh, so all I have to have is one of each? It doesn't matter what order I put it in?
It does matter. No, it doesn't matter.
Think about it this way. 4 times 5 equals what? 20. What is 5 times 4? What's 5 times 4? 20. Doesn't matter what order we multiply in. So it doesn't matter if this is this first and then this, or this first and then this. It doesn't. As long as you have opposite signs in the parentheses, you're good. So here's the thing. Should I ever get any of these wrong?
No.
Because once I get here, what can I do to check?
Repeat it.
Can't I just multiply it out? What's x times x?
X squared.
X squared. What's x times negative 8? Negative 8x. What is 8 times x? What's 8 times x? 8x. And what's 8 times negative 8?
Negative 64.
Negative 64. What happens right here?
You combine them and you combine 0.
That's 0, isn't it? So what do I have left?
X squared minus 64.
Oh my gosh, it's exactly right. Okay so far? Okay. I'll make this one easy. Is this the difference of squares?
No.
Why isn't it the difference of
has a
squares?
plus sign.
Oh, it has a plus sign. All right, watch how you do this one. Nah, fam, can't do it. You cannot factor the sum of squares.
So we just put...
They told me earlier that this meant not factorable. So that's why we're writing off fam. I know, they were being silly. It's okay. I can be silly too, right? Is it okay if you're silly when I'm silly?
No.
Absolutely.
No.
Okay? If you would rather put not factorable, you go right ahead. Excellent. Should I do that too? Okay. Not factorable. Whoops. Why is this not factorable?
Because it's not the difference.
It's not the difference. It's the sum of squares. Okay? Are you okay so far?
Yes.
Okay.
Oh, yeah. I'm ready.
Is this the difference of squares?
No, because that's not a square.
That's not a square. What? It's the difference of cubes. Are you sure? What times what equals x to the third?
X times x times.
So x, right? What times what equals 64?
4.
4. That's exactly right.
So do we have to make it in?
Gotcha.
So here's how you do it. There is a pattern, so let's learn the pattern. Fair enough? There's a binomial.
Wait, will there not be 3?
And now there's a trinomial. Difference of squares gives me 2 binomials. Difference of cubes gives me a binomial and a trinomial.
Whoa.
Don't whoa me as if I was a horse.
Does it matter which one's which?
Oh, yes. Yes, it does. It matters this time, okay? Let me say it real quick, just again. Difference of squares, you get 2 binomials. Okay? 2 binomials when you have difference of squares. Difference of cubes, you get a binomial and a trinomial. Okay? Now, there's a formula you could memorize. Who likes to memorize formulas? I'm not even raising my hand. Okay? But I know the pattern. Patterns are a lot easier to remember. So here's the pattern. What's the cube root of this? X. We're going to write it right here. For the record, the first one. For the record. Oh, we're not going there yet. We're not going there yet. We're just going to fill in the binomial. We're also going to ignore the sign for now. Fair enough? Okay, so what's the cube root of this number? So it goes right here. Now, I know the pattern for the trinomial because I already know the binomial. Okay? So to get the pattern, I'm going to call this one A and this one B. You okay with that? So when I go to the trinomial, this first term is A squared. So if this first term is X, what's this? X squared.
See, that's what I was asking you because I knew something was going to change.
Good job. This second term in the trinomial is AB. What am I doing with those? Multiplying, right? So if you know A and B, what's the middle term over here?
4x.
4x. Very good. What do you think this last one might be?
B squared.
B squared. Very good. And because you already know what B is, what goes right here? 16. Now we need to put in our signs. Okay? You ready for the signs? What's the one in the problem?
Negative.
It goes in the binomial. The next one is opposite of that. And the last one is always plus. Okay so far?
So wait, can we factor the addition of cube?
Pardon?
So that
Well, we're going to talk about that in a second. I want to do one that's similar to this one, a little bit harder, so you can make sure you're okay with it. Okay? Let's see. I'm doing it harder on purpose. You okay with that? Okay.
6, 4.
Like, how harder do you want it?
Like
Super hard?
Like I want me to be confused.
Like the hardest one we'll have on our homework.
Give me something you have trouble with.
Dude, what are you asking? You're asking to die.
3,000 y to the 9th. I thought she was going to make it harder.
She's going to give you a different homework. But like her math.
Please do.
No.
This one's pretty hard. So what's the first thing we have to decide?
Decide.
Is it the difference of cubes?
No.
Yes.
It is. It's 3 more than 9, right?
So it could be y cubed, y cubed, y cubed. That's y to the 9th, right? So that is, what about this one?
Yes.
It can be, what is B squared?
X squared, x squared, x squared. So those work, but what about the numbers?
Yes.
What times what equals 3,000?
I think it's 12.
Do you know how to find a cube root in your calculator?
Yes, X squared.
Let me show you real quick how to find a cube root in your calculator. Did you leave this on here?
No.
So somebody's still not clearing your calculator? Oh, great. Home. New document. Wow, that was so hard. Okay, so watch right here. Watch right here. Control, caret. See that? The up arrow? Control, caret. Look what it gives you. I can put in a 3 right there, which is a cube root, and a 3,000. Uh-oh.
Nothing.
What about 648? Does 648 have a cube root?
Yes. Probably 54. So is this an offense?
Oh no, we can totally factor it. Because what I notice is this. Man, I know the cube root of 1,000, right? I don't know the cube root of 3,000, but I know the cube root of 1,000, don't you? What times what equals 1,000? 10, right? So what if I divided this whole thing by 3? What do I have left if I divide each term by 3? 1,000 y to the 9th minus
2, 1.
216. Well, we already know the cube root of 1,000. Do we know the cube root of 216? Cube root of 216. Whoop.
6.
Oh, that's so nice. So is it really the difference of cubes? So I need to leave the 3 there, and I need a binomial, and I need a trinomial.
Okay.
What goes first in my binomial?
10.
10 y to the 3rd. Isn't that what you said it was?
Yes.
Okay. What goes in the second term of the binomial?
6.
6x squared. Good. So remember the pattern. How do I get the first term here? I square this one. What's this one squared? 100 y to the 6th. Right? 10 times 10 is 100. Y to the 3rd times y to the 3rd is y to the 6th. How do I get the middle term?
A times B.
A times b. What's 10 times 6?
60.
60 y to the 3rd x squared. And how do I get the last term?
You add them.
I multiply this one times itself, right? I square this last term. So 36 x to the 4th.
4.
Good. What are my signs?
Negative, positive, positive.
So whatever was in the problem is first. The next one is opposite of that. The
And that
last
one's
one,
always
always plus.
Good work, good work.
Why would I say it that way? I purposely said it that way, right? I said it twice that way. Whatever the sign of the problem is this one. This one's opposite of that. This one's always plus. Oh my goodness, we can. Look, we know how to do this one, right? That we also know how to do that one. Binomial, trinomial, same pattern as this one is. Hold on just a second. Cube root goes here. Cube root goes here. First term squared. First times the second. Second term squared. What is the pattern of the signs? What was in the problem? It goes here. What's the next one? Opposite of that. And what's the last one? Always positive.
So why can you do this one but you couldn't do the other one?
Because